Hello, friends, dear viewers. I welcome you all to the current session wherein we are going to take up the process that is the lower or plain course. Friends, I think you all remember that we were dealing with river and associated landforms in our earlier session. And in continuation of our topic, let us take up the lower or plain course of a river. The river moving downstream across a broad level plain is heavy with debris brought down from the upper course. Vertical corrosion has almost ceased, though lateral corrosion still goes on to erode its banks further. And now the work of the river is mainly deposition, building up its bed and forming extensive floodplains. Extensive floodplains. The volume of water is greatly swelled by the additional tributaries that join the mainstream. And coarse materials are dropped, and the finer silt is carried down towards the mouth of the river. These things we all know, dear friends. Of course, we are dealing them technically right now, or else we are very much familiar with the things which I am explaining, right? Large sheets of materials are deposited on the level plain and may split the river into several complicated channels so that it can be described as braided stream. Braided stream. Some of the major plain course features are the following, right? First of all, let us take up the floodplains, dear friends. Here, rivers in their lower course carry large quantities of sediments, and during annual or sporadic floods, these materials are spread over the low lying adjacent areas. A layer of sediment is thus deposited during each flood, gradually building up a fertile floodplain. Okay? A layer of sediment is thus deposited during each flood that gradually builds up a fertile floodplain. And I can give a beautiful diagram, dear friends, to portray the structure of a fertile floodplain. Right. When the river normally flows, its bed is raised through the accumulation of deposits and material. It also dropped on the sides, forming raised banks. I come again once again. When the river flows normally, its bed is raised through the accumulation of deposits, and material is also dropped on the sides, forming raised banks. And these raised banks are called levees. They are called levees. Make a note, dear friends. And it will not be long before the water level flows dangerously close to the top of the levees. And in an attempt to minimize the risk of floods, artificial embankments are erected to the natural levees, but this allows the river to rise further. Okay, this allows the river to rise further. When they can no longer withstand the pressure of the floodwater, the banks burst, damaging property and drowning thousands of people. The disastrous floods of this nature frequently occur in the Yangtze, the Kiang, Mississippi, the Po Valley, of course, the Ganges in India. The best known river for floods is the Huangho. It is Huangho, and that is popularly known as China's sorrow. Huangho is popularly known as China's sorrow. Basically, that is the river which is known for extensive floods worldwide, right? Here, millions of people were perished in in the history. Let us not go in detail, right? And now, the another feature, that is oxbow lakes. Oxbow lakes. These are also known as cutoffs or bayous. Cutoffs or bayous. This generally operates in Mississippi basin. Okay, and in the lower course of a river, a meander becomes very much more pronounced. The outside bend or concave bank is so rapidly eroded that the river becomes almost a complete circle. The river becomes a complete circle, and there will come a time when the river cuts through the narrow neck of the loop, abandoning an oxbow lake or mort lake. Mort lake, meaning a dead lake. That means mort lake means dead lake, a lake which is dead. The river then flows straight. The Oxbow Lake will later degenerate into a swamp through subsequent floods that may silt up the lake, and it becomes marshy and eventually dries up. And that is with the Oxbow lakes or cutoffs or bayous, etc. The next one is the delta. Friends, we all know very well deltas are the regions where the rivers stretches to meet the seas, right? When a river reaches the sea, the fine materials it has not yet dropped, they are deposited, they are deposited at its mouth, forming a fan-shaped alluvial area called a delta. And of course, this word is generated from Greek letter, and arithmetically we can imagine that delta shape, and from that delta itself, and that is from Greek only, we got this word. Friends, in resemblance also with that delta looks like this symbol delta only, right? This alluvial tract is in fact a seaward extension of the flood plain, and due to the obstruction caused by the deposited alluvium, the river may discharge its water through several channels called distributaries. And some deltas are extremely large. For instance, the Ganges Delta is almost as big as the whole of West Malaysia. And deltas extend the sideways and seawards at an amazing rate. The river Po extends its delta by over 40 feet a year. Okay, right. Of course, deltas are a number. And you find them in a more number where the size, shape, growth, etc. That carries a lot of importance, and we need not go in detail, friends. Here I'll try to give a diagrammatic representation for the formation of deltas and stages in the formation of a delta. Right now, uh, friends, I just given an example for Mississippi in the earlier discussion. Here, Mississippi has a bird's foot delta. Bird's foot, I mean delta which looks like a bird's foot, right? And this bird's foot delta, it is with several main branches like the foot of a bird extending into the Gulf of Mexico. Gulf of Mexico and the Nile, the Ganges, the Mekong have the fan-shaped arcuate deltas. You can observe the difference, friends. While we take Mississippi as an example, there the shape of the delta is like a bird's foot. And when taking the river Nile, the Ganges, of course the Mekong, we find the fan shaped delta, and that fan shaped delta is popularly known as arcuate delta, and with numerous tributaries. Some other rivers such as Amazon, the Ob, and Vistula have their deltas with numerous distributaries. Some other rivers such as um, maybe partly submerged with coastal waters, they used to form estuarine deltas. They used to form estuarine deltas. And a few rivers like the Ebro of Spain, Spain have tooth-like projections at their mouths. And these tooth-like projected areas, they are called as cuspate deltas. They are called cuspate deltas. So friends, don't get confused with things like bird's foot delta, which operates in Mississippi, the arcuate delta or fan shaped, that is with Nile and Ganges. Of course, the estuarine, while dealing with Amazon, the Ob and Vistula, and Ebro of Spain with cuspate delta. And these are the types of deltas, and I think we have gone very much in detail, friends. Now, the following it summarizes the conditions favorable for the formation of deltas, wherein active vertical and lateral erosion in the upper course of the river to provide extensive sediments to be eventually deposited as deltas. The coast should be sheltered, preferably tideless, and the sea adjoining the delta should be shallow, and no large lakes and no strong currents. These are the requisites for the formation of a delta. And of course, friends, we have the river rejuvenation also. And I think we need not go in detail into this rejuvenation process and all. But of course, a few things I would like to discuss, friends, like the terraces, the nick points, the gorges, the entrenched or incised meanders, etc. The positive movement also, and regarding this human aspects of rivers, friends, we all know very well. In many countries, the rivers generally they form the chief highways of the commerce or transport. Of course, Yangtze, the Kiang is navigable up to thousands of miles from its mouth. The Amazon, which is the world's greatest river in navigation, that is up to 2,300 miles upstream to the foot of the Andes Mountains, right? And if you want to know, I can give some more information also. Friends, even the Nile, which is, with its cataracts, is navigable for its first 960 miles up to the first cataract at Aswan. Other major rivers such as the Mississippi, St. Lawrence, the Rhine, the Danube, Congo, Murray, the Darling, Mekong, and Irrawaddy all serve as important waterways for their respective countries, and some of them are useful for transporting logs to the sawmills. Others are used to export bulky goods and import foodstuffs and raw materials. So, friends, I think that is enough for us. And to conclude with, uh, like irrigation canals also and wind gaps, and to sum up with the floodplains, dear friends, the floodplains of large rivers with their thick mantles of fine silt are some of the richest agriculture areas of the world. And this point should be noted, dear friends. And they may support a very dense population, and a chain of large cities may be strung around or along their banks. Many deltas are equally fertile, and of course, the Ganges Delta in India, and freshwater fishing, etc., and many political boundaries between many countries also they play an important role, right? Friends, I think it's enough for us to do with the landforms of running water, right? And now let us take up the landforms of glaciation, dear friends. Now let us deal with the landforms of glaciation. Before entering or moving into our main discussion, dear friends, I should give you some insights regarding this what glaciation or what glacier literally means, right? So, friends, the ice age and types of ice masses. These are the two things we should know first of all, and then we can go into our regular topic, that is landforms of glaciation, right? During the Pleistocene period, which is generally called as Ice Age, and that to about 30,000 years ago, where great continental ice sheets covered much of the temperate latitudes. Repeatedly, friends, we are coming across with the technical terms which have their roots in geography of various branches. Okay, I come again once again, friends. During the Pleistocene period or the ice ages, about 30,000 years ago, great continental ice sheets covered much of the temperate latitudes. It is estimated that more than 12 million square miles of the northern hemisphere were buried by ice, half of which was in North America and the rest in the Europe, Greenland, and the high mountains of Eurasia. Eurasia, right? Means Europe as well as Asia. The warmer climate that followed caused the ice sheets to retreat. And today, only two major ice caps are still present, that is, the Greenland and Antarctica. Greenland covers an area of 7 lakh 20,000 square miles, while Antarctica is more than 5 million square miles. Friends, it's clear, I think. And they are made up of compact sheets of ice, hardened and crystallized to a depth of over a mile. In Mary Bird Land, that is Antarctica, the ice cap was measured and found to be more than 14,000 feet thick. Under such a colossal weight, the land sinks gradually. From the central dome of the ice cap, the ice creeps out in all directions to escape as glaciers. So, friends, we got our word, that is glacier. Glaciers are glaciers are the ice caps, or it is the ice creeps which moves out or creeps out in all the directions from the central dome. And these ice caps are called as glaciers. Of course, the peaks of the loftier mountains project above the surface nunataks, as nunataks. When the ice sheets reach right down to the sea, they often extend outwards into the polar waters and float as ice shelves. They terminate in precipitous cliffs when they break into individual blocks. And these individual blocks, they are called as icebergs. They are called icebergs. While afloat in the sea, icebergs assume a tabular or irregular shape, and only one ninth of the mass is visible above the surface. And they diminish in size when approaching warmer waters and are eventually melted, dropping the rock debris that was frozen inside them on the seabed. A very interesting thing, dear friends. When these icebergs they are approaching the warm waters, they diminish in size or eventually melted, so that dropping down the rock debris that was frozen inside them on the seabed. Right. Apart from Greenland and Antarctica, glaciation is still evident on the high lands of many parts of the world which lie above the snow line. And this varies from sea level in the polar regions polar regions to 9,000 feet in the Alps, Alp mountains, and 17,000 feet at the equator, as on Mount Kilimanjaro. Permanent snowfields are sustained by heavy winter snowfall and ineffective summer melting and evaporation. So, friends, owing to gravitational forces and the neve of the upland snowfield is drawn towards the valley below, and this is the beginning of the flow of the glacier. In simpler terms, glacier is nothing but a river of ice. A river of ice. Glacier, it normally assumes a tongue shaped, broadest at the source, but becoming narrower downhill. Though the glacier is not a liquid, under the continual pressure from the accumulated snow above, it moves. The rate of movement is greatest in the middle, where there is little obstruction. Of course, the sides and bottom are held back by friction with the valley side spurs and valley floor. Valley floor. So it is the moving ice mass downslope under the impact of gravity, hence it is called a glacier. And dealing with the snow line, the line above which there is permanent ice where ice cover exists. Of course, ice sheets, which are the masses of ice which cover large areas of a continent, that is about the Antarctica and the Greenland. The continental glaciers, where they are in fact extensive ice sheets, and the Piedmont Glacier. Friends, make a note, Piedmont Glacier, and this is the glacier formed due to coalescence of several mountain glaciers at foothill zone. At foothill zone, Piedmont Glacier is the glacier formed due to coalescence of several mountain glaciers at foothill zone. Example, the Malaspina Glacier of Alaska, that is United States of America. Of course, the mountain glacier, that is the body of ice moving downslope under the impact of gravity. Friends, in the Alps, the average rate of flow is about 3 feet a day. In Greenland, it may be over than 50 feet. But in Antarctica, where there is little heat to melt the ice, glaciers move only a few inches a day. The Aletsch Glacier in the Bernese Oberland of Switzerland is 10 miles long, affording some spectacular sights to alpine tourists. Though it is the longest glacier in Europe, it is short compared with those of Alaska and the Himalayas, which measure more than 5 times that length, right? At the foot of the mountain ranges, several glaciers may converge to form an extensive ice mass. Just now I told that is called Piedmont Glacier. And the best known Piedmont glacier is the Malaspina Glacier of Alaska, right? And combined glaciers of such dimensions are now rare, and it is in most continents only valleys or alpine glaciers are seen, right, friends? It's time for us to deal with the landforms of highland glaciation. Landforms of highland glaciation. Now, friends, before entering into the process or the process of glacial action, we need to know about a few words like plucking, abrasion, erosional landforms, depositional works of glacier, erosional features, of course, the depositional features. These are the things we come across while dealing with the process of glacial action, dear friends. Plucking. What plucking literally means? In plucking, the glacier freezes the joints and beds of the underlying rocks that tears out individual blocks and then drags them away. So, plucking is the process where glacier freezes the joints and beds of the underlying rocks and tears out individual blocks and drags them away. That is about plucking. And abrasion. Abrasion is that where the glacier scratches, polishes, and scours scours the valley floor with the debris frozen into it. With the debris frozen into it. So, friends, I think it's enough for us, and hope think to wind up this session, and let us take up this session afresh with things like the erosional landforms. Hope you all enjoyed this session, dear friends. I once again thank you all. Thank you once again.